So graph this function and then convert to polar coordinates. Well, to graph this one with an x squared plus y squared equal a number, that would be a circle. Equal an x times a y, I have no idea. As well as there's this extra squared. So I'm actually going to have to change the order and do the graphing later. So start by converting to polar. So it's best to have these little formulas memorized, but if you don't, use a little right triangle like this, x and y values, the angles theta, and then there's the Pythagorean theorem would say x squared plus y squared equals r squared. And then if you do cosine, that's going to be x over r. So cosine of theta equals x over r, or if you solve for x is equal to r times cosine of theta. So that's going to help us out right there. And then use sine of theta is y over r. Solving for y, it's r sine of theta. And so over here we would have the x squared plus y squared gets replaced with r squared, and then it's squared. And then there's 2, and then x is equal to r cosine of theta, and y is equal to r sine of theta. And then this is r to the 4th. This is going to be 2r squared, and then I'm going to put them in order: sine of theta, cosine of theta. You could divide out a couple of r's so that these are gone. So divide by r squared on both sides. And then there's even an identity for 2 sine of theta times cosine of theta, namely that's sine of 2 theta. And then technically we could stop right now, but we still need to graph it, so I'm going to have to solve for r. That's going to be plus or minus the square root of sine of 2 theta. So as far as converting it, this would be much nicer, but as far as graphing it, I'll need to use this. So it's in polar form. It's going to be the square root of sine of 2 theta. There's also the negative square root, but it may be that the positive square root gives the whole graph. So let's see. The window, let's see, sine, the biggest it gets is 1, and the square root of 1 is 1. So negative 1 to 1, whoops, negative 1 to 1, negative 1 to 1. And then graph. And there's a piece of the graph missing right there, but I can take care of that by going to the window and changing this to be a smaller step so that it's going to graph more slowly and more accurately. So it looks like an infinity at an angle. But I should then do the negative square root, negative square root sine of 2 theta, and see, does that add anything to the graph? No, it looks like it's just regraphing it. You can see it's getting darker. So actually we only need the positive square root. And so this, you actually don't need the positive and negative. There's the graph.